Stoichiometry problems are problems about relating amounts of stuff, which are usually chemicals, through a balanced chemical equation. Sometimes you have to figure out what the chemical equation is from a word problem. A stoichiometry problem might sound like, how much hydrochloric acid is needed to react with, or how much carbon dioxide is produced when we... So these kinds of verbal cues are what you can look for that help you decide whether or not you're about to do a stoichiometry problem. There are several essential skills that are part of doing stoichiometry problems. So these are things that you have to be able to do first before you should attempt any stoichiometry problems. So you need to be able to recognize types of reactions. And by types of reactions, I mean precipitation reactions, acid-base reactions, etc. You need to be able to predict the products from those reactions. And you need to be able to balance chemical equations, just in case you were not provided one. You need to be able to calculate molecular weights. And you need to be able to do dimensional analysis, which is converting units of one thing into units of another. So all of these are essential skills before you can approach doing a stoichiometry problem. So once you have these skills, then you can think about stoichiometry problems as kind of a flow chart and follow the flow through different units. So for example, you might start with grams and need to go to moles, or you might start with volume or density. All of the time we're going to have a balanced equation and we're going to have a unit conversion at the same time. So let's look at an example so we can see some of this illustrated. So for example, I might have a problem that says that we need to make 5 grams of silver chloride using sodium chloride and silver nitrate. And we need to know how many grams of sodium chloride are needed. Okay, so there's that cue I was mentioning earlier, right? How many grams are needed? That tells you we're going to do a stoichiometry problem. So our first step that we need to do is we need to write a balanced chemical equation. So we know that we're using sodium chloride and we need silver nitrate, and we're making silver chloride. So we need to predict our final product, which is sodium nitrate. So once we do that, then we need to identify our flowchart progress. So when I talk about the flowchart progress, I mean that we are going to be thinking about where we're starting and what pieces we need in order to solve our problem. So if we think about the units that we're starting out with, we are looking at grams because we have been told that we need to make 5 grams of silver chloride, and we want to know how many grams of NaCl we need. So we're going to start with grams of AgCl. We're going to convert this to moles of AgCl. Through the balanced equation, we will use moles, our mole to mole ratio, to get moles of sodium chloride, and then we'll go from there to grams of sodium chloride. So that's going to be our flow. We're going to use the molecular weight to convert the grams to moles. We're going to use the balanced equation to go from moles to moles, and then we will use the molecular weight again, only this time the sodium chloride molecular weight, to figure out how many grams of sodium chloride we need. So in this particular problem, our step 3 is going to be to calculate all the quantities needed to support all of our calculation. In this case, we need the molecular weights. So if we're going to calculate the molecular weight, we need, here's silver chloride. We can look up the molecular or the atomic weight of silver. It's 107.87 grams per mole, and chloride is 35.45 grams per mole. And so if we add those together, then we get a molecular weight of 143.32 grams per mole. And for sodium chloride, sodium has an atomic weight of 22.99 grams per mole. Chlorine is the same. And so if we add those up, then we will get 57.44 grams per mole. So after we have our molecular weights, we can do the dimensional analysis step, which is our flowchart, and we'll cancel out any quantities. So we're starting with 5 grams of silver chloride, and we need to convert that into moles. So we use the molecular weight as a unit conversion. Grams go on the bottom to cancel out the grams, and that is the mass of 1 mole. From the balanced equation, silver chloride and sodium chloride are 1:1. And then our last step is to go from moles of silver or of sodium chloride into grams. And when we do all that, we will find an answer that is that 2 grams of sodium chloride are needed, assuming that it is our limiting reagent, to react with excess silver nitrate to produce 5 grams of silver chloride. And here, if you want to pay attention to this, we are keeping 2 significant digits in our answer because we started with 2 significant digits in those 5 grams of silver chloride. While I was explaining this problem, I was looking at my numbers and I realized that one of them did not make a whole lot of sense. So I was looking at this mass for sodium chloride and I thought, wait a minute, if I'm adding 23 and 35, I shouldn't get 57, I should get 58. So let's go ahead and update these numbers. It only changes our final answer by a little bit, but I didn't want you to be confused as you were looking at this and looking later and trying to figure out what it was why that was correct. So it was not correct. Let's fix it. But when we fix it, our final answer becomes 2.04 grams of sodium chloride if we're keeping 3 significant digits. But since we are only keeping 2 significant digits based on the original 5 grams, our answer is actually not going to totally change. Now is a good time to practice doing some stoichiometry calculations to make sure that you understand the process and that you don't have any questions. Of course, if you do have questions, please go ahead and ask me right away.